Well, that was absolutely fantastic. Thanks again, Sophie, as you're running out the door. I found that really inspiring, particularly as an early career scientist and a woman in science myself. So I'm really grateful for coming and talking to us today. So now we're going to move on to why we're here. To celebrate, don't save, I guess, probably shouldn't keep that. To celebrate our very own postdocs and early career researchers in our School of Psychology. We want to be able to share with you the amazing work they're doing. We want you to be able to hang around and talk about it and enjoy what we're doing and have fun. So to start us off, we've got John Maule. Yeah, I'm just going to bring up his talk. Yep, it's there. Excellent. That's a good start. John did his PhD at Sussex. Put the microphone on. If you want to wander, microphone. There we go. He's been a postdoc here for about 2 years now, and he's part of the Sussex Colour Group in Baby Lab, led by Professor Anna Franklin. Because all of our postdocs and research staff are people, I've also asked them all for a little fun fact about their life. What do they do when they're not here? And apparently last year, John created a scientifically informed art gallery for babies, which I really wanted to talk to you about, but now is not the time. So, yeah. So later on, when we're having coffee and when we're having our drinks later on, not only can you talk to John about the amazing talk he's about to give you, I suggest you ask him about that because I'm really intrigued as well. So we're going to hand over to John now. He's going to talk to you about too much information and how the brain processes our colourful world.
Thanks very much. Super. Thank you very much.
Oh, and I have to say, sorry, very briefly, we've been harsh. They've got 7 minutes and 7 minutes only, and then 3 minutes for questions. So we're going to give you a really quick whistle-stop tour, so stay with us. It's going to be fun, it's going to be fast, and go.
Great, yeah. Yeah, so that was a very uplifting start. There'll be no laughter, but don't worry about that if you don't laugh. So, in the wild, there's lots of colourful information. So we're surrounded by colours all the time, and there's lots of things that we want to do with colour. So if we imagine a world without colour, for example, you might go to the marketplace and you'll see something like this. There are some bananas there, but it's very difficult to extract the information that will help you make a decision about which bunch or which bunch you want to pick from. Or if you were at a football match, you might look across at the crowd over there, and it's actually kind of difficult to extract what's really going on there. Of course, when we bring colour in and we start to add colour information, then the decision becomes a lot easier. So you start to be able to see the information. You can see that there are 3 bunches with different stages of ripeness, and you can make a decision according to your personal taste. In the football match example, adding the colour gives you a much richer sense of what's really going on. You can see there are 2 groups of fans, separated by some stewards who are wearing another colour as well. So here, colour is being used to help us interpret the scene. And as a vision scientist, there are 2 things that really strike me about this. The first thing is that this process starts very, very early. So colour information starts to affect our perception of scenes within about 40 milliseconds, so about 400ths of a second. We're already processing colour information. The other thing is that our brain has to do something quite sophisticated in order to really process these complicated sets. And what it needs to do is it needs to pull out the individual elements, so the individual bananas, and they will vary slightly in colour, and yet still we're able to kind of extract a gist and still able to get the idea of what colours are there. So even though there's variation in the shirts, in the Manchester City side, we can still extract that those are their fans. So how does the brain do this? Colour presents a kind of processing problem. There's a lot of information there. We need to compress it somehow. One of the methods that the brain might use is to use summary statistics. So I'm going to talk about visual summary statistics. The idea of summary statistics is probably familiar to most of you. If I was to take the age of everybody in the room, then I could then average your age, and I'd be compressing all of that information about every individual into a single representation that's a bit easier to understand. So the same idea applies to visual stimuli as well. So you can give people in the lab displays with different size items. So if we give people a snapshot of this a set of different sized circles and ask them how big is it, it turns out they can average it pretty accurately. So they have a pretty good idea of what the average size was in that set. And that's despite having very poor knowledge about which individual sizes are there. So they have bad information about the individual elements, but they're able to extract the gist. And that's even if they just see it for about half a second. So can we do the same thing for colour? This is the question which I've been asking with some of my research. So if we see a snapshot of a set of different colours like this, are we able to, or is our brain able to extract the gist from that? Are we able to somehow integrate the information from the different elements into some kind of average? There are a couple of problems with this, a couple of reasons why averaging colour might be harder than averaging size. So one is that colour is kind of qualitative. So when you look at a colour, the experience of looking at red is quite different from the experience of looking at green. And it's not just one of quantity like size, it's really a qualitative sort of feeling. So that's one reason why it might be hard to average colour. Another is that colour is circular. So the way our brain constructs hue, although wavelength is continuous, our brain constructs it into a circle. So that's the basis of these hue circles that we have. So these are two reasons why averaging colour might be a bit hard. So in my experiments, the sorts of things that we do, if you come to the Sussex colour group and take part in one of them, then in the lab you'll see trials where you get a set of colours like this, and they'll be flashed up on the screen for half a second, and then they disappear. And then we can ask people different types of questions. So in one set of experiments, we asked people whether a particular colour was a part of the set. So based on their memory of the set, is this colour a part of the set? And from that, we can extract how much people get confused about what colours were really there. We can get an idea of, where they really think the colours were in terms of colour space. And it turns out that when we do this, people are really biased towards the average colour. So they will think that the average colour was a part of the set, even though it never actually appears in the set. Another question we've asked people is, which is the average colour? So we can give people two colours, so they have to choose between these two. And even when the two are quite similar, people are still able to very accurately extract the average colour from a set that they see very briefly. And we took that a step further and gave people completely free rein to adjust the colour however they want. So now they can just fix an idea of what they think the average colour was, and then make an adjustment, changing the colour of that patch. And again, they're extremely accurate. They get very close to what we think is the theoretical average. And they're very, very sort of tightly clustered around that. So we're not just interested in the average, we're also interested in other statistics of colour as well. So some recent research we've been doing has talked about variability. So you can ask people this question, which set of these two is more variable? And people are quite good at making that judgment. You can probably make that judgment now. But the other interesting thing about this is that it seems like people's judgments of variability are affected by what they've just seen. So if we flash up lots of really highly variable sets, it will bias their subsequent responses. It will make them think that subsequent sets are less variable. So it's a kind of adaptation effect. The eye is getting used to how much complexity there is in the world, and it's adapting so that subsequent sets look less complex. So to take this back to near to where we started, if we think about the world again, if we go from this abstracted idea back into the world, it's not very efficient for the brain to try and encode all of the individual colours in that scene. It is quite efficient for the brain to compress and average across there. So if you were recalling your memory of this scene of the fans, then it's more likely that what your brain would encode is something more like there was a blue section, a red section, and a yellowish section in between. There's no prizes for saying what flag that is. And in the marketplace, you get the same thing as well. So the same idea applies. You would probably remember that there was a bunch which was more ripe, a bunch which was kind of middling, and a bunch which was not very ripe at all. So this research, the idea that the brain is encoding statistics of colour, leads on to some really interesting further questions. So one is about what happens if you live in a quite different world. So if you live in a place where the colours are quite differently distributed, then, so if you're in the rainforest, for example, where it's dominated by green, or if you're in the desert where it's dominated by reds and browns, what effect does that have on your colour processing? And another way that we like to think about these questions is to think about the development. So at what point does the brain develop and optimise to its environment around it? And that's the subject of a forthcoming research project which will be going on, led by Professor Anna Franklin and funded by the European Research Council. So how does the brain compress all of the colour information around us? Well, It seems as though averaging colour and taking summary statistics of colour is one way that it can do that. And that gives us a really kind of tantalising insight into how the brain uses visual statistics to structure the perceptual world around us. Thanks.
We're not being harsh. Any questions?
I don't know if it's the OCD in me, but I noticed that each of your colour dots had 8 dots in it. And I'm just wondering if the pupil's ability to pick an average or fail to pick a colour set varies with the number of colours they've got to go. In other words, is it tactical ones or are they processing in a serial way?
Yeah, so we've done that experiment where we vary both the number of dots that are there and also the number of different colours that there are. So here we've got 4 different colours and 8 patches. We can vary those two things independently. But basically it doesn't really have an effect. So regardless of how many different colours there are, or how many patches there are, the ability to average seems to be the same. So that would speak to the idea that it's a kind of holistic average rather than serial processing.
Is it the same across colour boundaries? So if you've got a set of greens and a set of blues and a set of green and blues together, does that matter, those divisions?
Yeah, so the categorical boundaries that come with language, yeah, we've looked at that as well. So in this experiment, where we asked people to adjust the average, we also coded the trials for how many different categories there were in the initial ensemble. And that has no effect on how accurately people can average. So people average across categories as accurately as they do within.
Any more questions? Do you see any gender biases in the ability to average?
It's not something we've looked at. I suppose you might predict it based on something more general about local and global processing or something. But yeah, it's not something we've looked at. Not something I know a lot about.
Okay. Thank you very much, John.